So this is just to go into factor. We're just going to do sharp all our factors. So someone wants to start with Spidey today. Please. Thank you. Please. All right. Key factor left hand bracket, please. Okay, now the nice thing now about this, you'll see, wow, that's a beautiful quadratic. Those are two quadratics, so I can actually factor that. That was a little trick that I gave you, so you can see that. All right. Owen, can you factor this for me, please?
So your M&A
Yeah.
is -12 and -1.
Yeah.
So it's 2 and negative. No. Yeah.
No, it's okay.
Yeah, I messed up.
So multiply -12 and add to -1. What are the two numbers?
-4 and 3.
-4 and 3. So that's 2x squared minus 4x plus 3x minus 6. Okay. Kylie, what's key factor the right hand bracket for me, please?
We take the 2x, so it's 2x bracket x minus 2.
That's good. I meant this, but that's okay. We're not quite speaking the same language yet. That's okay. Albert, can you factor this for me right here, up here? Do one step.
Okay. X minus 3 is
Very good. Great. Matt, can you finish this? Like that. You guys are seeing the worst of me. I teach homeroom calculus next year, where my brain will still be fresh all the way through. Matt, what do I do with the middle bracket there, please? Good. That's -2x. 2x plus 3, x minus 2, x minus 3, and x minus 2. All right. And this is the part that you need to focus when you're doing this. What is this going to be? A positive or negative, even or odd function, please? Robin, go ahead. It is going to be negative. Good. Is it going to be even or odd? How do you know? Somebody help her? Go ahead.
Count out how many x's are if you multiply, so it's total of 5.
Yeah, if you were to FOIL this up, you have 1, 2, 3, 4, 5, right? So it's going to be negative x to the 5th, which is going to be odd. Okay. Sorry, go ahead.
So for the 0 for the -2x, the root of them is 0.
Root will be 0, yeah. All right, Joseph, what is the what's the end behavior of something that's negative and odd?
It would be as x goes to negative infinity, y would go to positive, and then it'd be the opposite way, where x goes to positive and y goes to negative.
Right on. If you want to call that Q2 to Q4, you may do that as well. Feeling sort of okay about that, I hope. Okay, let's look at my roots. I'm going to write down order 1 and order 2. That is a single root or a double root, okay? Order 1 and order 2. Foxman, what are my single roots, please, for this graph?
Okay, I have -3/2.
Good.
Then 3
Good.
and 0.
Now, just to make sure, okay, the 0 comes from right here, right? So again, that's going to be 0, -3 over 2, and 3. Notice your teacher was tricky. This is equivalent to x minus 2 squared, right? Because there's 2 of them there. So because there's 2 of them there, that is going to be an order 2 root at x equals 2. Are we feeling somewhat satisfied with this question so far? If you aren't, that's okay, but you know what you need to study in the next week. Okay, because there's like this little tricky one here. Yes, go ahead.
Why didn't you write x minus 2 as just squared?
I could have. I definitely could have. And you can do this, that's fine. I was just trying to stretch your little brains. But yeah, this is, you could have written as y equals -2x. 2x plus 3, x minus 3. Yeah, you could write that as well. Okay, let's get this graphed up here. Just actually, maybe before I do that, Elena Lawrence, if something is of order 2 for a root, what is that going to be when I graph it? It's going to bounce off. If it is order 1, what's going to happen to it? Go straight through, thank you, and I'll take it from there. Okay, so the order 2, 1 should bounce. I'm going to start with doing my end behavior, right? That will be the outside arm, and I'm just going to connect the dots after that. So here we go. I think I'm going to do it on graph paper today. I don't have to, but because I teach math. Okay, so here's my graph. I need to get to positive 3 and negative 3 over 2. Should be possible. Has anyone, I'm going to ask this, has anyone actually tried this at home for just comparing anything? Yeah? One person? That's good. Okay. A few of you guys, okay, right. It's good just to check on the computer, on the PC, or on your phone, just to sort of see to make sure. Because a lot of the stuff, you're sort of going on faith, right? To make sure that your graph looks good, right? So, especially next to higher order one, so it doesn't hurt. Just the last sort of check there. So, I'm going to write my roots on here. We're going to have negative 3 over 2, which is over here. 0 is there. 2 is there. And 3 is there. And behavior we said is x is negative infinity. Y is positive infinity, is x is infinity, y is negative infinity. It says we're going to have a single root here. At 2, it's going to be a double root. 0 is going to be a single. And 3 over 2 is going to be a single. So it's going to look something like that. Now, make your graphs nice and relatively big, okay? It's okay if you did it.
Oh, they're neat, actually.
This is a neat graph. Don't get me wrong. Don't get me wrong. This is a neat graph. But anyone see this though? Like at all? Right? So it probably wouldn't hurt if you could like make it at least 2 fingers big. Is that all right? You have big hands too, so 3 fingers big. You probably put up to 2 so you can see it, okay? It's a lot easier to make it at least. Again, I like the quarter of a page. You can go like it, make the glasses look a lot better. You know, that's one of their sort of easy to get up. Especially if you're giving it showing me an assignment. Right? It's very easy for me to look at it wrong. Okay, so sorry, Fox, you're my go-to guy. But I keep very close. Please don't drop the course. All right, I want to do 13A. I'm going to do 13A from last night, which was page 15 over 13A. Okay, the graph you guys could do, is this the transformations? Okay, so it says the graph of x to the 4. Y equals 1/4. Negative 2 bracket x minus 1 to the 4th plus 2. All I would ask you to do is to list the transformation. That's all I want you to do. Okay, that's all we're saying to do. Okay, so we'll do it in words here instead of in math. What does 1/4 on the left mean, please? Well, so there's nothing anybody here. Now, hold on, you don't have to raise your hand once. So this is your one to shine. Bailey, go ahead. Vertical stretch of 1/4. Okay. Now, basically, what does a vertical stretch of 1/4 mean? If it started off this big, what's a vertical stretch of 1/4 mean? Okay, smaller. It's only 1/4 of the size is what it's going to be. So really, it's a compression, right? A compression of 4 over 4%. Yeah. What does a negative 2 mean? Go ahead.
The horizontal question and
Why is it a reflection? Somebody other than Brian, pass there. Why is it going to be a reflection? Go ahead. Yes. Yeah, it's a negative, right? Yeah, right. So anytime there's a negative, you're basically multiplying your x, it's just going to flip across. If we have symmetry, that's not going to be an issue, but most routes are not symmetrical. What does the negative 1 mean, please? Somebody else? Go ahead. Okay, and the +2 is going to mean what, please? Go ahead. Okay. Axis is going to be, yeah, I'm not write that as a vertical shift, but it is the axis, yes. It would be axis if it was, you know, a sinusoidal, that would be axis, so vertical shift. And if you guys could graph that, that's fine, but basically that's just asking for it. Okay. Yes, that's right, okay. I don't know how to say it. Okay, we're good? Anything else from last night? Does that help? That's all. Anything else? Good. Okay, I can pause the video, then we'll get cracking here. Today we're talking about rates of change. Rates of change.